In this video, I'll cover hypothesis testing for a proportion. So we have a data set here which consists of a sample from a golf course, I think it is. And we are finding out the proportion of women amongst the golfers. And so we'll start by figuring out what the sample proportion of women golfers is. And so there's 400 golfers in my sample and 100 of them are women. And so the proportion of women is 0.25. We're going to do a hypothesis test, an upper tail hypothesis test for the population proportion being in the null hypothesis less than or equal to 0.2, and in the alternative hypothesis being greater than 0.2. Our standard error for the test statistic is calculated using that hypothesized proportion. So it's the square root of p times 1 minus p divided by n. And that comes to 0.02. And then our test statistic is p bar minus p, so the sample proportion minus the hypothesized proportion, all divided by that standard error. And that comes to 2.5. Our p-value, because we're doing an upper tail test, will be the tail area to the right of the test statistic. And we calculate that by the norm dist function will give us the area to the left of the test statistic. And so if we subtract from 1, we'll get the area to the right of the test statistic. And that comes to 0.0062. Our alpha for this test is going to be 0.05. And because our p-value 0.0062 is less than our alpha 0.05, we'll reject the null hypothesis in favor of the alternative. It looks like the proportion of women golfers in this population is bigger than 0.2 based on our sample. If we used a critical value approach, we would use the critical value 1.645 because that has a upper tail area of 0.05 to the right of it for a standard normal distribution. Decision rule for the critical value approach is if the test statistic 2.5 is in the rejection region, which for an upper tail test is to the right of the critical value, then reject the null. And 2.5 is bigger than 1.645, so we reject the null. Okay, let's see how that goes in Excel stat. So do a parametric test, test for one proportion, that's what we're doing here, test for one proportion. So first we'll type in the sample proportion, which is 0.25. Our sample size is 400. Our test proportion is 0.2. We're going to do a z-test, and the data is in the format of proportions up here. And under options, we're going to do a upper tail test. And significance level 5. For the variance, we'll use the test proportion. And okay. So let's just check our values, see if we got what we did before. So our test statistic, 2.5. Our critical value, 1.645. Our p-value, 0.006. 2 if we go out to 4 decimal places. So yeah, everything matches up. What if we did this as a two-tail test rather than a one-tail test? Well, everything up to here is the same. All these 5 numbers are the same. What differs is, because we're doing a two-tail test, our p-value now will be the sum of the tail areas to the right of 2.5 and to the left of minus 2.5. And that's going to be twice as much as the one-tail p-value, so 0.0124. Alpha's the same. Decision rule is the same. If the p-value is less than the alpha, reject the null, which we do. The critical value now is we take our alpha and put half in one tail, half in the other tail, and the value of z that will have 0.025 to the right of it is 1.96. Decision rule for the critical value approach is if our test statistic is in the rejection region, so because we're doing two tails, either bigger than plus 1.96 or less than minus 1.96, reject the null. We've got a positive test statistic, so the question to ask is this bigger than the critical value? And it is, so we reject the null hypothesis.